All right, here we go. I'm going to go slow, guys. This is from the 2007 ABBC exam. According to the scores, this is considered a hard question because look at what the average score was for AB. Out of how many points? 9. There are 9 points each. So this was considered hard. I have not looked at the rubric. I have not looked at it. I don't know. Let's read it together. This is the first time. And let's see where we land. You guys ready? All right. So it's a no calculator. And let's see. What do I have? I have a table here, T in minutes, and R prime, feet per minute. So I have some type of rate. I'm going to read it this time, guys, because every time you guys read it, I lose track of something and I mess up somewhere. So let me read it here. The volume of a spherical hot air balloon expands as the air inside the balloon is heated. Okay, that makes sense. The radius of the balloon in feet is modeled by a twice differentiable function of r of time t, where t is measured in minutes. Between 0 and 12, the graph of r is concave down. That's probably going to be important somewhere down the line. The table gives selected values of rate of change, r prime, of the radius of the balloon over the time interval between 0 and 12. The radius of the balloon is 30 feet when t equals 5. All right. The volume of the sphere's radius r is given by 4/3 pi r cubed. Bless you. Bless you square. Okay. Estimate the radius of the balloon when t equals 5.4 using a tangent line approximation at t equals 5. Underline tangent line approximation. Use your estimate. Is your estimate greater than or less than the true value? Give a reason for your answer. Well, I don't know. I guess we'll find out first. Bless you squared, bless you cubed. What do I need for a tangent line? Point and slope. They want it at t equals 5. Do I have a point at t equals 5? Yes. When t is 5, what's the radius of this balloon? So that's your point. Now I need r prime of 5. Do I have r prime of 5? Yes, it's in this table. R prime of 5 is equal to what? 2. There it is. Tangent line. Y minus 30 equals 2, parenthesis, x minus 5. Are we still all right? All right, move the 30 to the other side. I'm going to plug in what value? 5.4. So I'm going to go, let's see, I guess I'll leave it as y, and in a little bit I'll put it to an r. Y equals 2 times 5.4 minus 5, close it, plus 30. If you're scared, can you leave it like that? Yes. I'm going to say this. I'm going to write it like this. R at 5 is approximately, you don't have to, by the way. You can probably be fine like that. 2 times 0.4, 5.4 minus 5 is 0.4, plus 30. We're feeling pretty confident at the moment. So 2 times 0.4 is 0.8. So I'm going to say 30.8, and I need units. Feet. Are we okay? All right. Now it wants to know whether this is your estimate greater than or less than? Well, I don't know. I know this much. What is R? So if you have a concave down graph, it doesn't matter how your tangent line is. Look, boom, boom, boom. The tangent line is always above that curve. Do you guys see that? So with this estimate is going to be a greater, an overestimate. Now make sure that the reader understands why. So you're going to say your tangent line approximation is an overestimate. So I'm going to write, let me write it in blue.
Well, we just knew that, like, we didn't need to solve to figure that out.
Yeah, because it told us in the
because that it was complicated.
Your tangent line, or our tangent line approximation, is an overestimate since r of t is concave down. And you're probably safe with that statement, but I'm going to state a little more. As long as you don't say anything wrong, comma, meaning tangent line is above the r of t curve. There it is. That to me looks like full credit. I do not know how many points that was. If I had to take a guess, maybe 2. One for the tangent line, one for the approximation. Are we okay so far? All right. Yeah, I got you, miss. Some of you on the free response that we took, Mock 3, the very first question that they asked you on question 1 was rate of change of G at 23 or something like that. And I don't know, some of you guys did some crazy stuff. It's okay. It's okay. Yeah, look, that's why we're doing this, right? No, here, look, let's see. It was several of you. It was like a handful of you.
We'll see when we
Find the rate of change of the volume of the balloon with respect to time at t equals 5. Indicate units of measure. What am I finding? Yeah, I'm going to take a derivative, and but not for r. Let's see. So I'm going to find dv dt. And look, they were being nice. They don't have to. Do they tell me what volume is? There it is. So I'm going to write, don't worry, I see. Let me just write this real quick. 4/3 pi r squared. 4/3 pi r cubed. It was given. All right, what's up, you?
How did you automatically know, like, to find dVdt when they asked for volume?
As soon as they didn't ask for volume. They asked for rate of change.
Oh, what the rate of change
yeah.
of the volume?
If you see rate of change and you say volume, that's derivative. Now, if you see the word average, then that's the secant slope. So then you have to do y2 minus y1 over x2 minus x1. But if it doesn't say that, just find the rate of change. And notice, look, it's at a moment. It's at t equals 5. So if they don't give you an interval, that's even more hint that it's a derivative at that moment. Does that make sense? Yeah. So look, find the rate of change of the volume at what time? Yeah, they don't give you an interval. So they want the derivative at 5. Does that make sense? Rodriguez, you good?
I'm gonna hear the rain.
Oh, okay, yeah, no, okay, you can hear the rain, but let's make sure that we're also, yeah, because that heals the soul.
So if you told us that in the same problem that, like, oh, we started at t equals 0, and then what was the change at t equals 5, would that be just finding the derivative?
If they were to tell you something like, find the average rate of change between t equals 0 and t equals 5, that's not derivative, that's y5 minus y0 or whatever, v5 minus v0 over 5.
Okay.
Right? But this wants it at a moment at t equals 5. All right, here we go. I'm taking the derivative with respect to, well, t. dv dt equals, the pi is a constant, the 4/3 pi is a constant, so I take that 3 and I multiply by 4/3, so that's going to give you 4 pi r squared, and then I didn't take it with respect to r, I took it with respect to, so dr dt. Are we still okay? All right, now I'm going to write dv dt evaluated at t equals 5 equals 4 pi, parenthesis, do I have my radius at 5? Yes, it's 30. 30, close it, put a square, and then the dr dt at 5 is 2. Yeah.
Is this not calculator language?
No, because I don't even have a calculator. You can say v prime if you want, but this shows that you're taking it with respect to t. You know what I mean? Yeah. Are we still okay, guys? All right, no calculator. If you're scared, which after mock exam 3, I'm gonna let you guys know who if you're scared, leave it alone right there. I think right now we're not scared, so let's see if we can figure this out. 3 times 3 is 9, so 30 times 30 is 900 times 4. 3600 times 2. 36 times 2.
64.
Yeah. 6400 pi. Hold on. See? Okay, let's just go slow. 4 pi times 900 times 2. And then what should I do first? The 9 times 4 or the 9 times 2? Okay, so then 4 pi times 1800. 18 times 4. 18, 36, 72. 7200 pi. And I need units.
So the class as a whole should just leave it be.
I need units. Cubic feet per minute. We'll look at the rubric right now in a little bit to see how we're doing. Yeah. Maybe just leave it right here. Maybe just leave it right there, guys. I make mistakes all the time as well. Did I answer all the questions on that part? Okay. All right. More than likely, not always, but more than likely, if you have a table like this, you're probably going to be doing an LRAM, MRAM, RRAM, or trapezoid, one of the four options. And check it out. Letter C, look what they want. A right Riemann sum. Use a right Riemann sum with 5 subintervals indicated by the data in the table to approximate using correct units explained in terms of the radius of the balloon. Okay, guys, since there's so much to calculate, I probably would leave it alone. But let's see. We'll choose right now whether we're going to be brave or not. Is approximately, okay, a right Riemann sum with 5 subintervals. So I'm going to come back. Here are my 5 subintervals. Here's my first one. Here's my second one. Here's my third one. Here's my fourth one. Here's my fifth one. Do you guys see that? Because it's a right Riemann sum, they're just rectangles. Width times height. What's the width of my first rectangle here? 2. And what height am I using? So I'm going to go 2 times 4. I'm just doing width times height plus. And then the width of my next rectangle? 3. 3 times 2. So I'm going to go 3 times 2. That's the height again. Plus. And then the width of my next rectangle, 5 to 7, that's going to be 2 times what? I didn't see. 1.2 plus, and then let's see, where am I at? 7 to 11. So what's that? 4, 8, 9, 10, 11. 4 times what? Plus 1 times 0.5. Okay. I think there's a very good chance. I think we're going to be brave, but I think there's a very good chance because you're under duress and you're going fast and it's timed that there's a good chance you might make an error. So I think it's good to just leave it. Does that make sense? But let's see if we can do it. 2 times 4, what's that? 8. 3 times 2?
6.
2 times 1.2?
2.4.
And then 4 times 0.6? 1.2. Yes, 2.4. 2.4, right? Okay. 0.6, 0.6, 1.2, 1.2, 2.4, plus 0.5. Let's see. I think I can do those pretty easily. 8 plus 6, 14. And then can I do those easily? I'm just doing 2.4 plus 2.4. Is that 4.8? Yeah. Okay, so now let's see. 14 plus 4.8 plus 0.5. 18.8 right here.
19.2? No,
19.8, 0.5. 19.3. You got to be careful. I only recommend, and I'm not teaching to the test, guys, but I know some of you get the point here, and then, I make mistakes like that too all the time. All right, units. R prime of t was in feet per minute, and t, no, be careful. This is area under the curve, feet per minute, and then I'm multiplying by minute, which is time in minutes. So that's just going to be, no, just feet. Just feet, guys. Okay, let's talk real quick. Feet per minute times minute is just feet. If it were feet per minute divided by minute, that is feet per minute squared. Do you see the difference? Okay, let the units help you out. Look, this is multiplication. This is r prime of t times dt. So feet per minute times minute. Chav, if you don't, I don't like that, Chav. All right, it's area under the curve. So it's area under the curve. So look, here it is. This is it, time in minutes, and this is r prime in feet per minute. So think about it. Just do something really fast, shade it in. Feet per minute times minute. This is going to be in feet. Do you guys see that? I would like for you guys to see it just from the integrand. All right, now we're going to answer the second question. Explain the meaning integral of 0 to 12 of r prime of t dt in terms of the radius of the balloon. What does that 19.3 feet mean? It's a hot air balloon. What does it mean? Not how big the balloon is, but how much the radius has increased or grown. Does that make sense? So the radius has increased by 19.3 feet from t equals 0 to t equals 12 minutes.
Was it correct to say increase by a rate of?
No, because This is just how much the radius has grown or has increased. Does that make sense? Whatever the radius was at 0, my radius at 12 has increased by 19.3 feet because we're blowing hot air into it. Cool or not cool? Okay. So far, so good. I don't see why it was such a tough one. I mean, maybe I spoke too soon. Let's see what letter D says. Is your approximation in part C greater than or less than 0 to 12 r prime dt? Give a reason for your answer. All right, let's go back. I don't remember. Is r prime strictly increasing? The volume of the spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon in feet is small by twice the function r of time t, where t is measured in minutes. These guys are so smart, whoever wrote this question. These guys are so smart. So smart, those guys. R is concave down. What does that mean about r prime?
Oh, it's gonna be under over.
Why is r prime decreasing? R is concave down. So let me tell you it again, because I can see some of y'all's faces. Like, I don't understand what you're talking about. Guys, if r prime is negative, r is concave down. Well, if r prime is negative, that means r prime is decreasing. So look, if you are decreasing, so here's r prime. Look, it doesn't even matter the concavity of r prime. Look, here it is, decreasing, and here's r prime with a concavity of concave up. I don't know the concavity of r prime. I just know the concavity of r. If you do an r ram on a decreasing function, look, that's for if it's concave down, and look, it doesn't matter if it's concave up. It's still, is it an over or an underestimate? It's an underestimate because r prime is, no, don't say concave down. R prime is decreasing. Does that make sense? There it is. So that's what we're going to say. We're going to say our approximation in part C, our approximation in part C is an underestimate since r prime is decreasing. And using our RAM on a, you probably don't have to say all this, but this is just to hit a home run. And using our RAM on a decreasing curve gives underestimate. There it is. Yeah, that sounds soothing. Mental health. I think I'm perfect now.
No.
I'm kidding, guys. There's no such thing as perfection. Okay. Does all that make sense to you guys? I did not put the rubric in here because I did not want it to influence me. Should we look at it? Yeah, what year was this? 2007. The calculus AP exam has been since the 50s. Your grandpa probably took this exam. All right. Well, it's international. It's worldwide. Here it is. Letter A. I didn't use this notation. Did we get the right answer? 30.8. There it is. We got it. Since the graph of R is concave down on the interval, the estimate is greater than R of 5.4. We got the full credit. I like how we said ours. Letter B. DBDT. They give you 2 points for that. And check it out. We were confident and we got it. You could have left it like this. I tried to just highlight just this part, but dang it. Okay. I don't know how to highlight. You could have left it like the 4 pi 30 squared times 2, but we were brave and we got the 7,200 pi cubic feet per minute. Letter C. You could have left it like this on the right-hand side. And did we get 19.3? Okay, we got the point. And is the change in radius in feet from t equals 0 to t equals 12. I like ours better because we actually said that it changes by 19.3 feet. I like ours better. They're being lame. Okay, we're good. What's up?
I know it says like 7,200 feet per minute. If we didn't simplify it, would we still get the point if we were just like 4 pi 30 squared 2? Or do we
You gotta look at the very, very last point way down here. You see where it says units in B and C? So if you would have left the units out, but this right here, we wouldn't have gotten the unit point. But you still get the answer point. Letter D. Since R is concave down, R prime is decreasing on 0 to 12. Therefore, this approximation, 19.3 feet, is less than. I actually do like theirs a little better because it's more specific, but we still get the full credit. Does that make sense, guys? Okay. That was a good question. Do you guys feel good?
Yeah.
So did you think this one was hard enough that it should have been a 2.48? So maybe, yeah. I think you guys would have done better. I think when I get my scoring report, I think mine would have said above global average because you guys would have killed this one.
4.
All right. If you thought that one was hard,
What did you just giggle?
no, because this is one of the lowest ones. I don't know. I have not done it.
1 point.
Does this one require a calculator? Okay, take out a calculator, guys.
Oh, God bless.
This is like something you would do in a physics lab. Yeah, it looks like they're heating a wire. All right, we're going to go slow. This one requires a calculator, guys. Let me take out my calculator. Calculator. All right, here we go. 1.76 points. Man, that was brutal. The BC crew, this is, by the way, a question that the AB and BC share. 3.32. BC always has higher points, guys, because if you're in BC, usually that's like, who takes BC? Only the super nerds, So they didn't offer BC in my school, but if they would have offered it, I would have loved to have taken it. All right, here we go. Let's see what this is. A metal wire of length 8 centimeters is heated at one end. Why would you want to heat a metal wire? In physics, they heat stuff all the time, right? You never know. The table above gives selected values of the temperature Tx in degrees Celsius. I guess I messed up with the little degree symbol there, but that's fine. Of the wire X centimeters from the heated end. Okay, so this one's going to be the hottest, and then as you move away, it's going to get cooler because it's not the heated. The function T is decreasing and twice differentiable. Okay, highlight that or underline that because that might be pretty important. You guys ready? You have a calculator.
So twice differential means like.
You can it has a derivative and it has a second derivative.
Okay, so
Estimate T prime of 7. Show the work that leads to your answer. Indicate units of measure. T prime of 7. Is 7 in between any of these values? Between 6 and 8. So here's what you're going to do. T prime of 7 is approximately T of 8 minus T of 6 divided by 8 minus 6. Does everyone see what we're doing? We're just finding the slope. And no, it does. The 7 is, you want to use the smallest possible interval. The 7 is between the 6 and the 8. So here we go. 55 minus 62 divided by 8 minus 6. Now, yes, you could leave it like that if you wanted to, but this one is, so you probably should use your calculator, guys. So here we go.
So -7 over 2.
Is that what you got? I guess I could have just, 55 and 62, yeah. -7 over 2.
Use your calculator.
Yeah, you're right. 55 and 62. The difference is 7. -7 over 2. And it did say units of measure. Indicate units of measure. Sometimes I get it wrong. So the top is degrees Celsius, and the bottom is centimeters. Degrees Celsius per centimeter. There it is. That's it. What's up?
I was gonna ask, when is a function not when it's linear, right?
Whenever you have like a jump or a corner or something like that. But usually they will tell you, or it'll be very obvious. It'll be a graph. A corner, a corner derivative means that the original function is differentiable because it's the derivative that's not differentiable if you were to take a second derivative. You know what I mean?
Okay, so if the original function is differentiable but not the derivative.
That's okay. That would not be twice differentiable. But at least the original is. All right. Letter B. Write an integral expression in terms of T of X for the, an average temperature of the wire. I thought I was highlighting, but I was crossing it out. Average temperature of the wire. So let's see. Average might be 1 over B minus A, remember? Estimate the average temperature of the wire using a trapezoidal sum with 4 subintervals indicated by the data in the table. Indicate units of measure. Average temperature of the wire. Okay, this is the temperature of the wire. So it's average T of X. How do I do average? 1 over, and let's see, B minus A. So what is, from what to what? 8. 1 over 8 minus 0 integral 0 to 8 of T of X. You can write dt if you want. I put an X in there. Does that make sense, guys?
Yes.
All right, there it is. That's my average temperature of the wire between 0 and 8. And they want me to use a what? Trapezoid. If you have data like this, they're probably going to want you to do one of the 4, LRAM, RRAM, MRAM, or trapezoid. Trapezoid really is very similar to MRAM. Anyway, let's not get over this. All right, here are my 4. Chop, where are your 4 trapezoids? I don't know. Let's find them up. 1, 2, 3, 4. Do you guys see your 4 trapezoids? The delta X is your height. Cool? The Y values are your bases. So here it is. I'm going to put 1/8, and I'm going to write base 1, which is 100 plus 93 times, what's the difference between 1 and 0? 1 divided by, there's my first trapezoid, plus. Then I'm going to go 93 plus 70 times 4 divided by 2, plus
Were you dividing by 2?
area of a trapezoid is base 1 plus base 2 times height divided by 2, plus 70 plus 62 times 1 divided by 2, plus
62 plus 62 plus 55
times,
2 over 2.
and then close the bracket. If it were non-calculator, I would tell you to leave it alone. Do we have a calculator?
Yes.
Okay. I'm going to go 1/8, and then someone tell me what all that stuff on the inside of that bracket is.
Already.
Just a bracket.
100 plus 93.
Okay. I'll do it. I'll do it also. 100 plus 93
Oh, sorry, I thought you were asking us to call it out.
plus 93 and 70. Times 4 divided by 2, so times 2 plus 70 plus 62 divided by 2. 62 plus 55.
I had a number for sure.
If I didn't make any mistakes, here's what's inside the parentheses. 605.5. I haven't divided yet. I forgot. Oh, I think it was because I had a 4 on the top. So 4, I just did 4 divided by 2 is 2. And then on this one, I just canceled it. All right, divided by 8. Did you guys get 75.6875? 75 point, and I already forgot it. 6875. This is an average temperature. Degrees Celsius. Remember what we're doing, guys, and let me give you guys some hints. When you're working on this question and you're going super fast, if you get an answer like 50, could that be an answer? No, guys, look, the hottest this is 100. The coldest this is 55. There's no way the average temperature is going to be outside of this realm. There's no way it's going to be 50 or 40 or 30. Does that make sense? So make sure that the answers make sense when you're doing this. Cool or not cool? That fit that. What did I get? 75. Yeah, that 75 looks good to me. That 75 looks good to me. Somewhere between there. I like that. Let's see what we got next. Oh, I'm loving this. They're testing to see, FTC. All right, let's see what this says. Find the integral between 0 and 8 of t prime of x dx and indicate units of measure. Explain the meaning in terms of the temperature of the wire. What are you thinking, Ms. Kyle? When you see this question, what's going through your brain?
Area under the curve.
Okay, area under the curve. Area under what curve?
T of x.
No, not t of x. T prime. Do I have t prime?
No.
Nope, I just have t of x. So I can't do Riemann sums. I don't have an expression. What else should you be thinking about? Well, t prime is rate of change. Yeah. We're going to say.
Do we just need to think about it conceptually? Like we don't really have to do that.
No, well, you got to do something. What does this integral symbol mean? What's antiderivative of t prime?
T of x. Oh, so it's itself.
I was gonna say T of 8 minus T of 0.
Yeah. No, not over 8 minus 0. This is not an average. It's just t of 8 minus t of 0. You're just doing the antiderivative. So here it is. Integral between 0 and 8 of t prime of x dx is simply t of x. Put a line for evaluate. That's what it means whenever you start doing coding. That line means evaluate from 0 to 8. I'm going to put an equal sign, or I guess you could just do a new line. Upper minus lower. T of 8 minus T of 0. Do I have T of 8? What is T of 8?
55.
So I'm going to come over here. I'm going to write 55 minus, do I have T of 0? What is it?
100.
What's 55 minus 100?
-45.
Then I need units.
Degrees Celsius.
Degrees Celsius. Do they want anything else? Explain the meaning in terms of the temperature of the wire. Okay, what does that mean? What does that mean? Yeah, the difference between t equals 0 and t equals 8 is that at the end, you are 45 degrees cooler.
Cooler.
Does that make sense? That's what I'm going to write. The difference from the end that is being heated and the other end and the other end. See, I can't write English, comma. The other end is 45 degrees cooler. The other end, and then so the reader doesn't confuse myself. I'm going to put parentheses and say the end that's not being heated. The end that's not, bless you, being heated. Bless you. Is 45 degrees Celsius cooler. I haven't looked at the rubric. We'll see what the rubric says. Hopefully it says something similar to that. So far, I can't see why this has a 1 point something. I mean, it is tough. It's a lot of arithmetic, but you have a calculator, so yeah. And I guess it's relative because maybe that year. All right, you guys ready? Letter D. Are the data? Are the data? To me, that just sounds funny, but I just copied and pasted just how they had it. Maybe that's how they do it in New York. The Yankees. I'm not saying anything. They're just Yankees because they're in New York. Are the data in the table consistent with the assertion that t prime prime is positive for every x on the interval between 0 and 8? Explain your answer. Well, I don't have t prime prime. I have t. And do they tell me anything? T is decreasing. That's not going to help me because they want to know t prime prime. Okay, so here's what we're going to do. We're going to find an average t prime, or I guess a secant slope, and then I'm going to do the slope of that slope. Does that make sense? Like, what's the difference between 93 and 100? And -7 divided by 1? -7. So I'll put a -7 there. Do you guys see what I'm doing? The difference between 70 and 93, that's -23 divided by 4. We have a calculator, right? 70, 80, 90. So 23 divided by 4.
How do we know we need to be secant slope?
Well, I don't, but
I don't.
the only way to get the second derivative is to see the rate of change of the rate of change. Do you know what I mean? So I don't have a second derivative. So the only way I can get from one to the other, They're probably trying to see if you know MBT. They probably want to tie that in somehow. 5.75, negative 5.75. Can you guys see that number, by the way? And then difference between 70 and 62, that is negative 8. So negative 8. And difference between 62 and 55, that's another negative 7 divided by 2. So negative 3.5. All right, so let's look at my T prime values. This is negative 7. This is negative 5.75, negative 8, negative 3.5. Let's find the rate of change of this one.
Why?
Because that would be T prime prime. Oh, hold on. Or let's just look at it. Negative 7, negative 5, negative 8, negative 3.5. Oh, no. The answer is no.
No.
You can already tell just by looking at that.
Right.
No, yeah, because, okay, think about it, guys. This is negative 7, this is negative 5, so at the moment my T prime is increasing. And then look at the next one. Negative 8, and then back to increasing. If it were with the assertion that T prime prime is always positive, then this would always be increasing. Does that make sense? So the answer is no. So how are we going to write it? Are we going to reference it in terms of T prime or in terms of like let's do like a MBT type of thing?
Because of the negative 5.
Yeah, because I went from negative 7 to negative 5.75, like, you know, and then I went from negative 5.75 to negative 8. So I decreased, right? So I'm gonna make a statement based off of T prime, but I think they probably want me to make it. How should I say this?
No. Because.
Okay, no. Because what?
Your mom.
No, we can't say your mom.
No, because.
Help me out, Miss Houston. What would you say?
I don't get it. Or you can say.
You're referring to T prime. T prime is decreasing. This means that T prime is always increasing. But notice, I didn't get that.
You can say T prime is not consistently decreasing.
No, T prime is not consistently increasing. Which would occur if T prime prime of X is greater than 0 for every X in the interval.
I can see what this one's.
And I would, because this is an AP exam, guys, I would find a way to put this calculations down here. Like to put those calculations in here so the reader can see. Do you guys know what I mean? You know what? Maybe. Okay. Yeah, I'm going to do MVT. So just to show that. So I'm going to go. So T. What's my first? 93 minus 100. So I'm going to go 93 minus 100 divided by 1 equals negative 7 on 0, 1. That was from 0, 1, right? On 0, 1. On 0, 1. That's T prime. Average T prime. Average rate of change. Okay, let's do the other one. What was the other one? And this is a lot of work just for this one point. 70 minus 93. 70 minus 93 divided by what? 4. What did that equal? Negative 5.75. Okay, and then this is on 1 to 5. And then what was it from there? I'm just going to do it to this one because this one shows increasing. 5 to 6. 62 minus 70. 62 minus 70. So negative 8 on 5 to 6. And that's enough to show. See, from negative 7 to negative 5.75, that's increasing. And the negative 5.75 to negative 5, that's decreasing. Do you guys see that? I hope that the reader will understand. I think that's full credit. If this came to me, I would say, yeah, that looks correct to me. Full credit. Of course, I would probably check it with the table leader, and I would side on your side, and I'll say, yeah, the kid shows understanding here. They're finding me the average rate of change, which is like T prime, and they're showing me that it increased and then decreased, so it can be possible. Should we look at the rubric for this one? Letter D was probably the hardest one. Letter D was probably the hardest one. What year was this? You're right. Okay, here it is. Did we get the answer for letter A? Yep. Did we get the answer? Oh, wow. Letter B was 3 points. They give you a point for the one ace with the integral 0 to 8 of t of x dx, a point for the trapezoidal sum, and a point for the answer. 75.6875 degrees Celsius. All right, we got it. I like our answer better for C. The temperature drops 45 degrees from the heated end of the wire to the other end of the wire. I like ours better. Ours is better. And letter D. Yeah, they wanted you to reference MVT, but we're still fine. Average rate of change, temperature 1 to 5, negative 5.75. Average rate of change, temperature 5 to 6, negative 8. No, by MVT. Okay, we got it. It would have been better if we would have said MVT, but that's fine. There it is, guys. And then for units on A. Oh, did I lose a point? Did I have units on A, B, and C?
C, yes.
And B?
Yes.
All right, we got it. How do we feel? Are we getting stronger? Yeah, I think we're getting stronger. We got 2 free response questions. Relax. I don't want you guys to finish them today. Or if you can, that'd be great. The 2 are in groups. I put how many points. I didn't put for that one. Maybe because that one was a Form B. Yeah, that's a Form B. But I put it for the other one. And then if you have questions, let me know. And then I have 2 questions that I would like for you guys to do solo. You can look up the scoring guidelines just by Googling that year and just putting scoring guidelines. And then tell me how many points you got. And if you have questions on how to score, let me know. Is that cool, guys? All right. That's it, guys. If you want to take a little break, take a little break. But to make sure we take care of business.